Hello students, and welcome to the 7.06 honors teaching video. To be working on this assignment, you should have already completed the 706 regular assignment. But before we get into that, I do want to just talk real quick about the standards. This will be similar standards to the regular assignment. Again, if you would like to read over these, you can click on or pause this video and read over them. You can also access them in the course information by clicking on Standards. The objectives here will be to basically define oxidation reduction, assign the oxidation numbers, and of course we're going to actually balance an equation using the half reaction method. So as I mentioned a moment ago, you do want to make sure you've already attended the 706 lesson, and also the 305, 403, 404, and 405 is some background information that will help you better understand this lesson. If you are still not comfortable with the regular lesson, please go back and attend the help sessions, the tutoring, watch the videos, those type of things to make sure you have good mastery of that before you attempt the honors assignment. Alright, so for the honors assignment, as I mentioned, we're going to use what's called the half reaction method to balancing equations. And this works, of course, with redox or oxidation reduction type of reactions. A half reaction is simply when we take the reduction half and we write out that reaction, and then we take the oxidation half and we also write out that reaction. So we have kind of half of the situation, because remember, they both happen together. So we're looking at just the oxidation, we're looking at just the reduction, but we have to keep in the back of our minds that both are occurring simultaneously. Now in oxidation, because the electrons are being removed or given off, they will be written on the product side. Reduction, because we are gaining electrons, they would be written on the reactant side. So if you look at the example down here at the bottom, we have tin metal reacting with a copper ion, yielding zinc ion and the copper metal. So the zinc goes from neutral to +2. So to do that, it had to give up 2 electrons. It had to get rid of 2 negative charges. So that will be oxidation. Zinc metal yields zinc with the ion and 2 electrons. Whereas the copper goes from 2+ to neutral, so in this case it had to gain 2 electrons, take on 2 negative charges to cancel out the 2 positive. So that would be written on the the reactant side. So we have 2 electrons plus the copper ion yielding the copper. All right, so this is an example of an oxidation half reaction and a reduction half reaction. And you can see by combining these two together, we would end up with the original reaction that we have up here, because the electrons would cancel out. Okay, if we combined these two reactions together, we would have zinc plus the Cu ion, the copper ion, and we'd have 2 electrons, yields the zinc ion plus copper plus 2 electrons. So because we have 2 electrons on both sides of the equation, they cancel out. Oops, try that again. There we go. Leaving us with the original equation. And that's actually one of the rules that we'll get into here in a moment when we start doing these. Alright, so there are, of course, steps that we need to go through. The first part is actually what we did back in the regular assignment. We have to first figure out what's being oxidized and what's being reduced. Once we know that, we can then split things up into the 2 half reactions. Once we have our 2 half reactions, then we're going to do a series of steps to both reactions. first thing that we need to do is balance all elements except hydrogen and oxygen. Then we're going to balance oxygen by adding water to the other side. And we can do that because these reactions are happening in aqueous solutions. So there's plenty of H2O around. Then we balance the hydrogens by adding H plus ions to the opposite side. And again, the reason we can do that is because if we are in an aqueous system, we also have hydrogen ions floating around, as we learned back in the beginning of Module 7 when we talked about water being amphoteric. So there's some H plus ions and there's some OH minus ions. Okay, now because we added hydrogen, we also added some positive charge. So now we got to basically cancel out that positive charge by adding electrons. So we balance the total charge by adding electrons to the side with the higher overall charge to bring it down to equal the other side. All right, now if the number of electrons lost in the oxidation half reaction do not equal the ones gained in the reduction half reaction, then we need to multiply one or both by a multiplier to make them equal. All right, in other words, we've got to get that common factor. Once the electrons are equal, then we just add the two half reactions together to get our final balanced equation. And of course, all these steps will make a little more sense here as we walk through an example together. Before we do that, I just want to mention a couple tips. All right, if you have equal amounts of the same substance on both sides of the equation, like with the electrons, then they're going to cancel out, kind of like in the example I just showed you a moment ago with the zinc and copper. If the same substance is on both sides but with different coefficients, then you can reduce it. So one side it'll cancel out, the other side will just be reduced. And then if you have the same substance on the same side of the equation, then you would just add them together, combine them together to make it one list, and then of course you would change the coefficient accordingly. All right, so again, like a lot of things, the best way to do it is just to look at an example. So let's do that. We have H2S plus HNO3 yields sulfur, nitrogen monoxide, and water. All right, well, the first thing, again, we have to do is determine what's oxidized, what is reduced. All right, so we have to assign oxidation numbers. So let's start with our first compound here. Hydrogen is in group 1, so that tells us it's +1, right? There are two of them in H2, so that means we have a total of +2. Therefore, we must have -2 to cancel it out. There's only one sulfur, so it keeps all of that -2. All right, for HNO3, hydrogen again is +1. We only have one hydrogen, so it's going to stay +1. Oxygen is -2. We have 3 of those, so that's going to give us 6, right? -2 times 3, so it's a total of -6. Now to make that all cancel out and be 0, since we have a neutral compound, we would have to have +5. All right, 1 plus 5 is 6, -6 equals 0. There's only one nitrogen, so nitrogen keeps that entire +5 for its oxidation state. Now on the product side, sulfur is by itself, so it's automatically 0. Okay, oxygen we know is -2, which means the nitrogen would have to be +2 to make everything cancel out. And then for the water, again, oxygen is -2, hydrogen is +1. We have 2 hydrogens, so that's going to give us +2 total, which would cancel out the -2 from the oxygen. All right, so to determine then which ones oxidize and reduce, we got to find the ones that changed oxidation state. So sulfur goes from -2 to 0. That would be one of them. Hydrogen goes from +1 to +1, so there's no change there. Nitrogen goes from +5 to +2. So that would be the other one. That changes. Oxygen goes from -2 to -2, so no change there. Alright, so now we have to write our two half reactions. The one half reaction, we're going to have H2S, and that's going to yield S. On the other side, or the other half reaction, we have HNO3 yielding NO. Alright, so the next step was to balance everything but hydrogen and oxygen. So in the first one here, we've got one sulfur on the left side of the arrow and one on the right side. So they are balanced as they are. For the second one, we've got one nitrogen on the left, one nitrogen on the right, so they are balanced. Okay. Next step is to balance the oxygens by adding water where needed. Well, in the first reaction, we don't have any oxygen, so we just leave it as it is. Now, if we go to the second one here, we have 3 oxygens on the left side, and we only have 1 oxygen on the right side. So we need 2 more on the product side. So what we're going to do is we're going to add 2 H2O. Now I have 2 oxygens here. I got the one that was already there, so that gives me 3 total oxygens on the product side to balance out the 3 oxygens on the reactant side. Next step is to balance hydrogen. Okay, so when we look at the first reaction, we have 2 hydrogen on the left, which means I'm going to have to add 2 hydrogen ions on the product side so that we can balance it. I'll do the same for the second reaction. I have 1 hydrogen on the left. I have 2 times 2, so I have 4 total on the right. So I need 4 back here on the reactant side. Well, to do that, I already have 1, so I'm going to have to add 3 hydrogen ions on the reactant side. Okay, so now my hydrogens are balanced. Now I have to balance charge, because I just added some positive charges here, right? I added 2 positive charges. On the left side, I have no charge. So to get this back to no charge, I would just simply add 2 electrons. Now I have 2 positives and 2 negatives. When I add those together, that equals 0. And that will be equal to 0 from the left side. In the second equation, same thing. I have 3 hydrogens here. So I'm going to kind of squish it in here, but I would add 3 electrons to the reactant side. So now I got 3 negative and 3 positives. They cancel out to be 0, and of course there's no charge on the product side. So now I have my 2 half reactions. Now the next thing I have to do is make sure that I have the equal number of electrons in both. Well, of course you can see I don't. I have 2 electrons in the first one. I have 3 electrons in the second one. So I have to get a common factor between those two. And of course the common factor of 2 and 3 would be 6. So what I'm going to have to do is I'm going to have to take the first equation here, and I'm going to have to multiply the whole thing by 3 so that I get my 6 electrons. So now I would have 3 H2S yields 3 sulfurs plus 6 hydrogens plus 6 electrons. And then for the second reaction, again, if I multiply one part, I have to multiply the entire thing by that same factor. So in this case, it's going to be 2. Now I'm going to write it underneath the other one here so we can kind of add them together for the next step. So I'm going to have 6 electrons plus 6 hydrogen ions plus 2 HNO3 yields 2NO plus 4 H2O. Okay, just multiplying everything by 2. Alright, now the last step is to add these together to write our final equation. Now if you notice, I have 6H plus on the right side of the arrow, and I have 6H plus on the left side of the arrow. So I can actually cross those out, because that tells me that they did not react since I have them on both sides of the arrow. Same thing is true for the electrons. I got 6 electrons on the product side. I have 6 electrons on the reactant side. Your electrons will always cancel out. If they don't, then something's not right and you need to go back and double check it. Alright, so now when I combine these together, I will have 3 H2S plus the 2 HNO3, right? I'm combining both reactions now. So I got to take the reactants from both of the half reactions and put them together. Yields all the products. So I have 3 sulfurs plus 2 nitrogen monoxides plus 4 H2Os. Alright, and that is how we would use the half reaction method to balance a redox equation.